We're in 14.1, the law of sines. And the law of sines is really valuable, just like the area formula, because we do not need a right triangle in order to do it. So I'll show you what it is. Here's the law of sines. And as before with this just scalene triangle here, we have to be careful about how we label it. We have vertices A, B, and C. And then we have side A that is opposite vertex A. We have side C opposite vertex C, and side B opposite vertex B. And as before, it doesn't really matter which one is A, which one's B, which one's C, as long as we're consistent, because it's equal from any perspective, right? So the sine of angle A, right here, over side A, that ratio is the same for side B, angle C, and C, right? So each angle and opposite side for a triangle, or the sine of each angle and the opposite side have the same ratio. So when can we use this? Well, we need to establish what this ratio is. So we can use this whenever we have, say, a side and the opposite angle, right? We need that to establish the ratio. And then we need just a little bit of information. Any other single piece, either an angle or a side, can help us figure it out. Because as soon as we get a angle, we can figure out the third angle of that triangle, right? And then we can figure out the opposite sides. If we were given a side, then we can figure out an opposite angle, and then we can figure out the other angle, and then we can figure out the opposite side. So I'll show you what I mean here in a second. So here's our triangle. We have triangle RST. We know angle R is 33. We know angle S is 35. And we know side R is 18. That's all the information we're given. So first things first, we can figure out what angle T is pretty well, right? At this point, this should be pretty routine. Just as soon as you see a triangle with two known sides, or two known angles, just figure out the third one, because you can, because it may make your life easy. And now we need to use the law of sines to solve for this. So bear with me. Sorry about that. So we're going to set up our proportions. And whenever we set up these proportions, instead of doing all three, right, we're not going to set up all three of these equal to each other. We're just going to focus on two, right? Because we just need a single equation, a single equal sign in order to solve for an unknown. So we're going to set it up so when we have our sine A over A equals sine of C over C, something like that, where there's only a single unknown. And I'll show you which one we have here. We have the sine of angle T over side T is equal to the sine of angle R over side R. And only one of those, only one of those values is the unknown. The other three we can actually plug values into. So we'll plug in our known values, and then we'll plug and chug, as they say. Similarly, we can set up our other side over here. To do that. We have our other side over here. We have the sine of angle S over S equals this known ratio again, right? So that's why we chose the sine of angle R over R. So we know three of these four values. We can plug in our known three values, right? And then we can solve for the unknown. The unknown is just this value down here. Again, as a reminder, algebraically, since it's in the denominator, it's going to be a couple steps. You can multiply both sides by t, and then divide both sides by the sine of 33 and multiply both sides by 18. Or you can cross multiply and then divide both sides by the sine of 33. Or you can flip both sides and then multiply both sides by the sine of 112. Whatever it takes, regardless, you'll end up with something like this. Stick it in a calculator, you get an answer. We can do the same thing over here, a little bit further. Same thing over here, plug the values in, stick them into a calculator, you should get 19.0 for our two unknown side lengths. So I'll give you guys a second to go ahead and try and figure out 4 and 5 here. For this guy, we know 2 of the angles. We know 1 of the sides, right? So you should be able to figure out the missing angle and then figure out the 2 missing sides in the exact same way as our previous example. This one here is a little different. We only know 1 angle. So, however, we know 2 sides. So you're going to have to use the law of sines to figure out angle C. Once you figure out angle C, you'll use triangle sum theorem to figure out angle A. And then you'll use law of sines again to figure out side A. So go ahead and take a stab at that. Let me know how that goes. Pause. Okay. Sorry for the wall of text here. Well, for number 4. For number 4, the correct answer for angle A should be 110 degrees. Then we can use the law of sines. We set up our ratios. You can either solve for side C first or side A first. Regardless, you should have the sine of 28 degrees over 8 somewhere in there in order to solve for both of those. So that gives us A is approximately equal to 16. When you solve for angle C, or side C, you should get approximately 11.4. For this guy over here, again, we use the law of sines to solve for angle C first. That gives us 42.9. And then we can, don't forget you have to use the inverse cosine here, right? Or sorry, the inverse sine. So you use the inverse sine of 15 times the sine of 33 over 12. So a lot of steps there. If you need to, break it down into multiple, into decimal halfway through, that's fine too if you need to. It's a little less accurate though. Then once we find this angle, then it's pretty easy to find angle A. We can just do that using some good old subtraction. And then once we have angle A, we can use law of sines again to find side A. So side A comes out to 21.4. So good job if you got those. I'm going to pause here. STEM classes have to watch my other video because it has important information for them. So we'll see you in class.